The electromagnetic spectrum.
There are 7 parts to the electromagnetic spectrum. A good way to remember them are: good xylophones use very interesting musical rhythms. The parts are gamma rays, X-rays, ultraviolet, visible light, infrared radiation, microwaves and radio waves. Radio waves are divided into long wave, about 1 to 2 kilometres in a wavelength. A radio station, Atlantic 252, broadcasts here. Medium wave, around 100 metres in wavelength, used by BBC Radio 5 and other AM stations. VHF, which stands for very high frequency and has wavelengths of around 2 metres. This is where you find stereo FM. Radio stations such as BBC One and further up to the VHF5 are civilian aircrafts and taxis. UHF stands for ultra high frequency, has a wavelength of less than a metre. It's used for police radio communications, television transmissions and military aircraft radios, although military communications are now mostly digital and encrypted.
Microwaves and radio waves. Microwaves and radio waves can travel at large distances and through the atmosphere. They can even travel across space. Microwaves are basically high-frequency radio waves. They are made by various types of transmitters. In addition, microwaves and radio waves have low frequency and are at the bottom end of the electromagnetic spectrum. Microwaves are used in many appliances, such as to carry signals in wireless and Bluetooth devices, and satellites use microwaves for navigation. In addition, microwaves can cook food by heating up the water particles within the food with dielectric heating. Microwave radiation can harm the body, as it can send radiation to the eye and cause it to lose its transparent layer. This is called cataracts. Microwaves in phones can also damage the brain when you put it to your ear. It penetrates and heats up the brain with radiation. This can cause tumours to form in the brain, although many scientists don't believe this to be true. Infrared radiation is the 3rd lowest frequency on the electromagnetic spectrum. The existence of infrared radiation was discovered by William Herschel in the 18th century. Most energy from the sun arrives on the Earth in the form of infrared radiation. It is used in industrial, scientific and medical appliances. Other uses are night vision devices that use infrared radiation to allow people or animals to observe without the observer being detected. It is also used to observe the changing of blood flow in the skin and to detect overheating in medical apparatus. All objects emit and absorb thermal radiation, which is also called infrared radiation. Infrared radiation is used in astronomy. Like in space, there are many regions which are hidden from optical telescopes because they are embedded in dense regions of gas and dust. However, infrared radiation, having wavelengths which are much longer than visible light, can pass through dusty regions of space without being scattered. This means that we can study objects obscured by gas and dust using infrared radiation, like the centre of our galaxy and regions of newly forming stars. But the equipment needed for this process is very delicate and it takes a lot of time just to produce one picture. Also, accurate measurements are limited to earthbound infrared levels, which makes the calculations very difficult.
The visible spectrum is the portion of the electromagnetic spectrum that is visible to the human eye. Electromagnetic radiation in the range of wavelengths is called visible light or simply light. A typical human eye will respond to wavelengths from about 390 to 750 nanometers. In terms of frequency, this corresponds to the band of invenicity of 400 to 790,000 Hz. A light-adapted eye generally has its maximum sensitivity at around 555 nanometers. In the green region of the optical spectrum, The spectrum does not, however, contain all colours that the human eyes and brain can distinguish. Unsaturated colours such as pink, purple and variations such as magenta are absent, for example, because they can be made only by a mix of multiple wavelengths. Visible wavelengths pass through the optical window, the region of the electromagnetic spectrum which allows wavelengths to pass largely unattuned through the Earth's atmosphere. An example of this phenomenon is that clear air scatters blue light more than red wavelengths, and so the midday sky appears blue. Our eyes can detect only a tiny part of the electromagnetic spectrum called visible light. Ultraviolet light is made by special lamps, for example on sunbeds. Another name for ultraviolet light is UV. UV light attracts insects which are electrocuted by high voltage wires near the lamp, so they won't land on the food within other shops or restaurants. Uses include suntan, detecting fake banknotes in shops, and hardening some types of dental fillings. Also, UV lights are used in clubs where they make clothes glow. In addition, UV light kills microbes. Hospitals use UV light for sterilising surgery equipment. Also, UV rays cause body to produce vitamin D in suitable doses. However, large doses of UV light can damage the retina and cause sunburn, which leads to skin cancer.
X-rays have the second highest frequency on the electromagnetic spectrum. X-rays are very useful as they are used in hospitals to see if you have a broken bone or anything like that. This is because X-rays pass easily through flesh, but not easily through denser materials like bones or metal. So it is the amount of radiation absorbed that gives you an X-ray image. However, X-rays can cause cancer, so radiographers wear lead aprons and stand behind a lead screen or just leave the room altogether.
Gamma rays are used in medical screenings to trace the passage of blood and other substances around the body. A radioactive liquid called a tracer is injected into the patient after a time a special picture is taken. Many cancers form deep inside the body for this reason. Penetrating gamma radiation is the most commonly used to attack tumours in the cancer treatment. The instruments that doctors use are sterilised by gamma radiation. The radiation kills microbes and bacteria that could lead to infection in patients.
Light and other types of electromagnetic radiation are transverse waves. Water waves and S waves are also transverse waves. In transverse waves, the vibrations are at right angles to the direction of travel. Sound waves and waves in a stretched out spring are longitudinal waves. P waves, relatively fast moving longitudinal semantic waves that travel through liquids and solids, are also longitudinal waves. In longitudinal waves, the vibrations are all along the same direction as the direction of travel.